WINFra BRIDGE. I am Rahul. I am a structural engineer at WINFra Technical Consultants. Today, we are going to talk about how to design foundations in STAAD Foundation. Through these videos, we will understand how to import structural reactions from STAAD Pro to STAAD Foundation. Then, provide parameters necessary for the design of foundations. Then we will understand what type of foundations can be designed in STAAD Foundation and the parameters necessary for those type of foundations in the design. Finally, we will understand after analysis and design how to interpret the values given in STAAD Foundation. Thank you.
Today we'll be discussing on how to design foundations, isolated foundation footings and combined footings. We'll discuss how we can design these two types of foundations in STAAD Foundation. So I have a model here. First, we will analyze this model. Okay, so analysis is finished. Now we will go to post-processing. Now, if you see here, there is a foundation design workflow here. So you go there and then select the foundation nodes, the support nodes. So usually when we design warehouse foundations or anything, there will only be support nodes at the bottom of the column. So you don't need to select anything. Instead, it will directly take all supports and then you just give the load combinations or cases, whatever you want to design the foundations. Here in this case, since there are supports at this location where columns will be, the beams will be connected to the existing RCC structure. So I'll select these support nodes, and then I only want to design the foundations for these load combinations. Now it depends on you. Like if you want to design only for the load cases, if you have a different load combination that you need to input, then what you can do is you can just select these load cases and then include them and then go to STAAD Foundation. Or if the design is already done as per the if it's already done for the same load combinations you have added in STAAD file, then you can use the same load combinations. Click include. It will include all the load combinations, and then you just click STAAD Foundation Advanced. So it will directly take you to STAAD Foundation. So here you can see all the node numbers, everything here. Now, okay, in some cases, like when you open the STAAD Foundation, all the units, everything will be in feet or other units. So you can go to unit setup and then reset the units to SI unit and then click OK. It will automatically reset the units. Now here you can see all the column positions that you have imported from STAAD. Here all the column positions will be shown. These are nodes. The same node numbers will be followed here. And then column dimensions. Here all the column dimensions we have provided. ISMB, it doesn't matter which steel members, if it's steel member or RCC members, it will show the dimensions of the columns here. Now you can go to pedestal or anchor bolt design. You can see all the column sizes given. All these column sizes were imported from STAAD. So whatever column sizes you have given for those members, it will show here. All those sizes will be shown here. Now you can go to pedestal and anchor bolt design. Now it will not design anchor bolt, and also it will design pedestal, but it's not really accurate. So, but we will have to give pedestals here. So since if you are using steel members, you will have to provide pedestals, right? So here you can just give. It will ask if you should consider pedestals or not. If you want to consider, you just click yes. It will ask you to give all the details for the pedestal dimensions. So for me, okay, for this building, the foundation will be at 3 meter from NGL 3 meter below NGL, and then the pedestal size. Now I am going for same size. Okay, so I will be giving pedestal length 0.6 meter everywhere. Now for pedestal height, they ask pedestal height, which is from the top of footing, till the top of the pedestal face. So in some cases we will have pedestal projected out of NGL, right? So that projection plus what is the depth of the pedestal from NGL to the top of the foundation slab top. So that here I'll give, let's consider, this will be just arbitrary value. Let's say if you are giving 500 foundation thick slab, then 3 meter minus 0.5 will be 2.5. And then if you include 300 projection from NGL to top, then it will be 2.5 plus 0.3, 2.8. So I'll give 2.8 here. So what I did was, so you have a pedestal here, and then there'll be a foundation slab. Okay. And this will be the NGL. There will be a height, a projection from NGL here. So that will be, let's consider here 3.3 meters. Now what I was saying is, if this is the foundation thickness, let's say it's 500, let's take it as 0.5 meters. And we know the depth of the footing is 3 meters. So this height will be 2.5, right? So the total height of the pedestal will be 2.5 plus 0.3, 2.8. It depends, like it will change if the foundation thickness changes. According to that, you can change it later. But just consider, let's consider that this will be the height of the pedestal. So you update it here, pedestal height as 2.8 meters. And then you go to loads and factors. Here, since you imported all the details from STAAD file, everything will be shown here. Now, there is one thing you have to do here. Usually, you don't need to, but here you will need to change this primary, the load type as primary to services or ultimate. What STAAD Foundation does is, it will consider this as primary and it will check the foundation sizes for all load cases, including serviceability, and like it will also consider foundation sizes for ultimate load case also, load combinations also. That is not what we usually do, right? We usually check for serviceability load combinations and then design the reinforcement details according to primary, as per limit states method. So what you need to do is you need to change the status here. All the you select all the ultimate cases and make it ultimate. Change it to ultimate load combinations. Then select all the serviceability load combinations and then mark it as serviceability here. This will make sure that it will check. So this will make sure that STAAD Foundation will check foundation sizes for serviceability load cases only. If you open one if you open one load combination, you can see all the all the reactions, everything here. Like it's all taken from STAAD. So you can see it here. Now this is saved. Now go to job setup. Here, this is where you need you create a foundation. You create which foundation you want to design. So for now, like I said before, now we will discuss isolated and combined footing design. So first we will go for isolated footing. Just give a name here. Now here in job type, there will be different types of foundations you can choose. today I will be doing for isolated footing. Now design type will go for Indian standards. Then version, which version of Indian standard code you have to use, IS 456. Then default unit type SI units. Now the support assignment there will be different types of assignment, support assignment. Either you can assign to all supports, like you can assign to all supports. Whatever job setup you have created, it will be assigned to all supports. Or you can just select supports in such a way, you can select some supports, and this job setup will be applied to only those selected nodes. Now, assign to listed supports, here you can give a list of supports where you want this to be considered. So let's go for assign to all supports. Now you include all the load cases, all the load combinations, everything that you have that you have imported from STAAD. Then create the job. Select create the job. So it will automatically select all the nodes and then assign these isolated support job. Now you go to isolated footing job. Here you will have to give all the details necessary to design the foundations. So here, first one will be concrete and reinforcement. Here you will have to give the concrete unit weight, bar spacing, concrete characteristics and strength, then steel yield strength, everything you will have to give it here. So unit weight of concrete, we usually go for 25. Then minimum bar spacing is 100. Unit weight of concrete is 25. We'll type it here. So minimum bar spacing is 100. Now maximum bar spacing, we don't usually go beyond 300. So I'll give 300 here, 300 mm. Now strength of concrete, it depends on different jobs. For this case, we'll go for M30 concrete. Now yield strength of steel will be 500 MPa. Now it asks for minimum and maximum bar sizes for the footings. So if you give these sizes, minimum and maximum bar sizes, what it will do is it will take this range and then design the reinforcement details according to this range. So I'll give 12 mm as the minimum bar size for the footing bottom of the footing, and then maximum bar size will be 25. For top, I'll give minimum bar size 12 and maximum bar size 25. So minimum pedestal diameter spacing, all these, usually I don't use this because the pedestal reinforcement given by STAAD Foundation usually will be much higher or uneconomical, so we don't go for that. Now we go to cover and soil. In this tab, you will give all the details required, details of the soil, and the soil, you will give all the soil properties here. So here pedestal cover, you just keep it as 50. Bottom clear cover of foundation, usually I give 75 mm. Now unit weight of the soil, that unit weight of the soil, you can get this unit weight of the soil, then base pressure, soil bearing capacity, then depth of the footing. All these you will get, all these details you will get it from soil report. So if you go through the soil report, you will get all these details. So let's take unit weight of soil as 18 kilonewton per meter cubed. Now here soil bearing capacity, let's consider as 100 kPa. Now this part, this is multiply on soil bearing capacity for ultimate loads. So if you go to home and then go to global settings and go to this rigid footing foundation settings, it will ask if the bearing capacity setting for input will be either gross or net bearing. So if you go to if you go and read the soil reports, they usually give you net bearing capacity. Net bearing capacity will be the capacity of the soil, excluding the backfill soil. So if you see that there is a equation CNC plus gamma Q, gamma B and Q. There are a lot of equations. There are so many terms. There are 3 terms. The first term will be the second term of this equation will be the capacity due to the backfill soil. So if you are considering gross bearing capacity, STAAD Foundation will automatically include the backfill soil weight and then find the maximum bearing capacity. Usually in soil reports, they give you net bearing capacity. So net bearing capacity will not include any backfill soil weight there. So here we will consider it as net bearing capacity, because this setting will change the sizes, and based on the bearing capacity of soil, it can be even higher. Like if you give gross bearing capacity and then check the sizes, and also if you change it to net bearing capacity, there may be a significant change in the foundation sizes also. So first you need to change this setting. Now, if you have changed it to net bearing capacity, you don't need to give any multiplier here. So this will be 1. Now depth of soil above footing. So this depth of soil above footing will depend on the type of depth here. So I have mentioned here, like there will be a top face and bottom face here. So if you are giving fixed top type of depth, what we'll do is we'll consider the soil depth up to top of the footing slab. So that depends on the foundation thickness also, which it has to arrive, which STAAD Foundation has to arrive. So what you can do is you can change the type of depth to fixed bottom. So what it does is, like, the soil depth of soil you are giving will be taken from NGL to the bottom of the footing slab, which will be the depth of the foundation. So directly you can give depth of the foundation here. So here I told you before, foundation depth will be 3 meters, which will be 3000 mm. Now surcharge pressure will be if you have any surcharge load, I mean any live load on top of this, on top of NGL. Let's say, like, if you have a grade slab from where you expect to have a very high surcharge load due to any vehicle or any equipment usage or something, you can give the surcharge here. Usually, since we don't have any surcharge pressure, we don't consider it here.
Hope you understand the sessions. If you have any comments, please let us know through the comment sections. Thank you.